science is not about hitting the same spot. It's about hitting the right spot repeatedly, and that is why we need the idea of precision and accuracy. And in this fundamental physics lecture, we are going to talk about precision and accuracy. Now, precision means small. So, precision is the degree of closeness of the measured values with each other. For example, if you get values 10.01, 10.02, 10.03, these values are very close to each other, we can call them precise. On the other hand, accurate means correct. So, accuracy is the degree of closeness of the measured value with the expected or accepted value. For example, gravity value is 9.81. So, you get the values 9.80, 9.82, 9.83. These values are very close to the expected value 9.81. So, we can call them precise. Now, let me show you this with a dartboard. Unfortunately, I have only 2 darts. Since the darts are all near the bullseye, I'll make a third eye with the pen. Then they're accurate because all in the bullseye. This is where we expect the dart to be, and also the precision is very small because they're very close to each other. But if you make them a little far away, but still hitting close to the bullseye, then it's not precise, but they're accurate because it's hitting the right place. Now, if they're much far away from each other and the bullseye, then we say they are not precise because they are far away from each other, and they are not accurate because they are not close to the bullseye, or their average is not close to the bullseye. And if they are at the far away from the bullseye but they are close to each other, then we will call them precise because they are very close to each other, but not accurate because they are far away from the bullseye. Now, I already wrote some notes, and I do believe that they are going to help you, so we are going to go through them. Now, precision is the degree of closeness of the measurements with each other, and it's also about getting consistent results. So, values are very close to each other. It mainly happens if something is not accurate but precise, it happens due to the systematic error. There is some problem with the calibration of the instruments. So, it depends on the measuring tools, and also it is determined by the number of significant digits. For example, if you measure something with a ruler and then again you measure with a vernier scale will be much more precise because it can measure a smaller distance. Now, how do you get rid of them? We can get rid of them through repeat experiments, okay, so that the average value is more close to each other. Then we can use group measuring. Group measuring means, for example, if you want to find the height of a coin, you can measure the height of 10 coins and then divide it by 10 to find out the height of one coin. Then you can use high resolution tools. That means you can use a screw gauge or vernier calipers instead of a ruler to measure the distance. So, you can see it mainly happens when you have better tools. Now about accuracy. Accuracy is the degree of closeness of the measurements to the expected value, and so more near you are to the expected value, we call it more accurate, and it depends on the person measuring, because if they are not accurate, it mainly happens because of personal errors. And so if the person is uses standard ways to measure it and he is very careful, the results will be more accurate. Now, this one is important, how to find out the calculate the accuracy. Now, percentage error, measured value minus expected value into 100 by expected value. So, this shows the ratio of the error to the expected value, and then show it in a percentage. This is something you are going to need a lot. We usually accept 10% error, but it varies from experiment to experiment. Now, how to get rid of the inaccuracy? One thing is you calibrate the instrument, because if your instrument is wrong, then you won't get the correct value. Then you follow the standardized techniques. You make sure there are no environmental errors. So you control the environment, and you prevent personal errors such as parallax error. Now we also draw a graph over here. We have this probability. See, this is, suppose this is the accepted value. Suppose this is 9.81, and you got values, say this is 11, the average. So this difference between 9.81 and 11, that is how accurate the value is. And suppose for this result 11, the minimum value you got was 10.5, and the maximum value you got was 11.5. So this distance from 11.5 to 10.5, this one is the precision. So they're close to each other to 1 millimeter. That is why we say it depends on the measuring tool, because this last digit or the difference here, 11.5 minus 10.5, this depends on what measuring tool you're using, and so it depends on the significant figure. That is, and the reason why significant figure is important. So to memorize or to understand, you can write this. Precision basically reduces spread. So the values are close to each other, it reduces spread. On the other hand, accuracy reduces error. That means you are close to the expected value. Now, if you want a better video, you can follow me on Facebook, YouTube, or Instagram as Asghar Ed, which is more about the education. That's all for today.